Okay, good day, everyone. I want to welcome you to today's lecture on MATLAB series. We are in module 3, and we shall be looking at MATLAB basic operations today. I want to assume that you have installed MATLAB on your device, and we have gone through the module 2, which dealt with MATLAB windows, where we discussed command window, edit window, live script, workspace. You get to be familiar with those windows so that you can flow, especially with live editor. So today we shall be dealing with MATLAB basic operations. Let me share my screen. I expect you to have your computer by your side. Possibly, I think the best approach would be to have your screen by your side, your computer by your side, and possibly you listen to the lecture via your smartphone so that you will be doing exactly what I'm doing, because the lecture is going to be hands-on. My name is still Dr. Ekenesa Marimbona from Federal University of Technology, Owerri. Okay, so we go ahead with the lecture. I will be making use of two presentation documents. One is PowerPoint presentation, and the other one is MATLAB environment. So basically, these are the two things I shall be working with. Okay, let's prepare the whole thing. Okay, so let's go to the business. MATLAB basic operations. When MATLAB is invoked, the command window will display the prompt. We are familiar with that, this prompt. That's what we mean by that prompt. And then when you finish doing what you are doing, you can use quit or exit to exit the MATLAB environment. Then if there is anything you want to find out, probably you need help, all you need to do is to type help. Probably you want to find out about compressed number. What you need to do is just type help, provided you are connected to internet. You strike enter, and then it will give you a number of options. You can see what we have here is a compressed number not found, showing related topics. So it shows you compressed pay, imaginary number, real number. However, it tells you start documentation for compressed number. There is MATLAB, there is a document called MATLAB documentation. You can use it to search for compressed number. And once you click on it, if you have your computer connected to internet, it will take you to MATLAB Help Center, where you can really learn about compressed number. You can see that, but we are not dealing with compressed number today. So let's close it up. We proceed. That's how to use help. Now, with MATLAB, we enter commands in form of variable and the expression. If you enter values on your command window without assigning it a variable, MATLAB by default will assign it answer. And the answer is not stored. Anytime you type in another thing, say 67, it will replace the former one. So I'm sure it's not a feature you will want to have. You would want to store your variable. So if you want to have your variable stored, call it a name, say temperature is equal to 25, then it's stored. You can now store even another value as another thing, say humidity is equal to 34. That's that. And then you can always call up your stored value, temperature will always come up again. And that's it. So that's about variable and expression. Now, MATLAB stands for Matrix Laboratory. Whatever we want to put in MATLAB must come in form of matrix. And if you're familiar with matrix operation, rows always come first before the column. So if we have, let's go to a live script so that our lecture can flow. If we have, I think I need to minimize some of these windows. Let me close that one. Let's close this one as well. We don't need it. And then let's work with so if we have matrix, so we have a matrix, this matrix or any matrix at all. Let's say A is equal to A is equal to, sorry, let's say A is equal to 1, 2, 3. That's 1 space 2 space 3. Let's assume is the first row, and then the second row 27 4 6, and then the third row 2 9 2 9 0. How do we enter this in MATLAB? What we can do, you call it A. So you come to the code section. A is equal to, you open your bracket, you enter the first row, 1 space 2 space 3. You separate the rows with semicolon, and then 27 4 6, and then you separate it again, 2 9 0. When you run this program, you run this section, the value of A will come out. We want the value to come just below the A, so we have to use output inline so that it doesn't come at the right hand. Having done that, we can now run the section. So it's running, you can see it's running. So that's it. That's A. That's A. That's the matrix. And then all the matrix operation you can as well do. You can do all kinds of things, matrix inversion, determinant, all of them are there. For example, if we say determinant, 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 determinant of A is equal to A, that is DET, that is A. You run again. So you have the determinant of A as 675. You can also get inverse of A. Inverse A is the one on the left hand side is just a variable. What is important is the one on the right hand side, which is a function. You can name the one on the left hand side anything. Inverse A, you run it, it gives you the inverse of A. So that's the inverse of A. So that's it. All kinds of things can be done. Matrix, when we talk about MATLAB basic operation, we're talking about plus, minus, multiplication, division. If we define, talking about addition now, let's define another matrix. Meanwhile, let's clear the output. Let's define another matrix, B, to be equal to 2, 3, 4, 3, 4, 5, 5, 6, 7. So if we say, let's run it and see the output. So that's A, and that's B. And then if we say A plus B is going to add element by element. That is, we expect that we are going to get a matrix equal to 1 plus 2, whose first element is 1 plus 2, then the second element 2 plus 3. Let's just do it and see what I mean. This is A plus B. Run it. You see that? So you can see that if we bring in check the results, A plus B, that is 1 plus 2, 2 plus 5 is 7. So the third row, first column must be 7. That's it. You can also do A minus B. For matrix addition and matrix multiplication, the number of, if you have n by n matrix, that is, and B is equal to P by Q matrix, for the matrix to be able to multiply, the number of columns in the first matrix must be equal to the number of rows in the second matrix. We don't have problem with D being equal to A multiply by B. It will go because the dimension are equal. But supposing that we have, let me suppress this so that we can proceed. Let's assume that we now have a B that is 2 by 2, or rather, let's say 2 by 2, is not going to work. If we say A times B, it's not going to work. It's not going to work. Definitely, it will show us an error. Array have incompatible sizes for this operation, so the matrix dimension must agree. But let's assume this is 3 by 3, so let's get a B that is equal to 3 rows by 3 by 3 means 3 rows and the 3 columns. So let's get a matrix that is 3 rows and 2 columns. 3 rows and 2 columns. So this is a row, 3 row, 2 columns. Okay. This 2 columns. So let's try now. This is I mean, this matrix, if we display B here, if we display B and suppress, remove this one from the whole thing, what is B? B is 3 rows and 2 columns. So let's have 2 rows and 3 columns and see what will happen. 2 rows and 3 columns. Okay, so sorry about that mix up. So let's continue. Let me share my screen again. So the number of rows and the number of columns in the first matrix and the number of rows in the second matrix must match. Here we have the number of columns is 3, 1, 2, 3. Then here we have 3 rows, 1, 2, 3. So we execute that and see what the result will give us. So that's that. We proceed. We can always get out the elements of the matrix. We can always pick them out. For example, if I want to pick this one, I simply execute A, let's say that is a 1, 1. That is first row, first column. That is the first element. First element of A. First element of A is equal to that, and you can check it out. So that's 1. The second element of A is row 1, column 2. You check it out again. That's value we change to 2, and then the 1, 2, 3. The fourth element is row 1, row 2, column 1. You do that, you are going to get 27. So you can always pick out all the rows and all the columns. For example, if I want to pick all the rows in all the rows, say all the elements of the first row, I can say for all rows, then this should be the command for all rows, let's say all columns, row 1, all columns, row 1. Let's see what I just hope I'm correct at this point. Let's see what it gives us, whether it will throw an error. Yeah, all rows, there's nothing here. So we are interested in row 1. I mean, for row 1, all columns. If we're interested in that of 2, row 2, all columns, we get to have 27, 4, 6. If we're interested in just the column, say for all rows, column 1, let's see, what did it give us? You see 1, 2, that is 1, 27, and the 2. So that's how to get all these to work. Let's proceed. You can always find the size of a matrix. For example, if you execute size A, size A, size A, you get a dimension. It's a 3 by 3 matrix. That's it. Okay? And we make progress. If you want to find the list of variables you have been using, all you need to do is to type whos, just type whos. Remember, MATLAB is case sensitive, and then you run the section. It will get you the list of all the tables, everything you have been doing. So this is what I've been doing so far. And they will tell you the class, and they belong to the number of bytes they've occupied in the MATLAB memory. And now we proceed. So there are things you may want to find out. Probably you are looking for demo of something, you are working, you want to see a demo to at least to learn. All you need to do is to type demo. Let's do that at command window, but you can equally do it here anyway. You can equally do it in so let's suppress this or let's remove this entirely, and we suppress this, then we suppress this, and we just type demo, and we run. Sorry, I don't mean to. What happened? Okay, we run. So it brings out all the possible demos you can have. You can see AI, data science, statistics, MATLAB demo, Simulink, physical modeling, control system. You can actually open any of this. Probably you want to run a demo of what now? Workspace. You just click on it and wait patiently for it to open up. It can take a little time to open up. MATLAB is a heavy file depending on your system speed. But you can see it has opened up, opening up gradually. It's like I clicked some other things before clicking the other one. Let's just run MATLAB demo. Let me just click on that. Let's see. So it just bring you to this page where you can actually learn some of these things. You can click anyone. You can see you can now begin to learn some of these things one after the other. You can see many of the things I was saying are here. This is MATLAB demo. Okay, you can also, after that, getting started with MATLAB, you can click next. It's just a demo. Array indexing and etc. etc. So we proceed. And then you can find the length of a matrix or a vector if we have temperature equal to 0 and space of 2 up to 100, we can actually find the number of elements in the temperature by typing length temperature, and it will give us the number of elements. So that's 51. That's 51. And when you do clear, we will clear everything that is in the workspace. I think we've talked about that before. CLC clears your command window. CLG clears graphic window. Diary saves a session in the disk, possibly for printing at a later date. So that's that. At this point, matrix division. I would like you to pay attention to this because we are going to use it for tutorial. Matrix division. Matrix division can either be left division operator, that is backward slash, or right division operator, forward slash. We are used to forward slash. The right division, A for B, for instance, is algebraically equivalent to A over B, while the left division, A backward slash B, is algebraically equivalent to B over A. If Z times I is equal to V and Z is a non-singular, it's non-singular, the left division, Z left divided by V, is equivalent to MATLAB expression I is equal to inverse of Z multiplied by V, and the right division denoted by V over Z is equivalent to the MATLAB expression I is equal to V in times by inverse of Z. These two expressions are not the same thing. They are not the same thing. MATLAB multiplication is not commutative. It's not commutative. It's not like 2 times 3 that is equal to 3 times 2. No. Okay, so we move on as we round off for today. There are also some matrices or command you can use to generate special matrices. This is for advanced analysis. You may not know what they can be used for now, but for sure, as we begin to progress, you will see where some of these things can be used for analysis. If you say once, if you say once, 3 by 4 is going to give you once, 3 rows, 4 columns. Everything 1. Can see that if you say zeros, it's going to generate it. You can use it to create a memory. You can use this one to create a memory. Where you want to store something, zeros. And you can find the diagonal of a matrix by executing diagonal A. And when you say I matrix, it will give you something similar to identity matrix. I matrix, let's see what it gives us. And I, look at the command. I gives n by n identity matrix. So I 4 gives us identity matrix, okay, of 4 rows and 4 rows and 4 columns. Having said that, we move on to tutorial section. We want to apply some of the things we have learned in engineering now. Look at the question for the bridge network shown in figure 1. Find the currents I1 to I5. The currents I1 to I5. This is peculiar to engineering students or anybody offering a course on DC circuit analysis. Okay, people in the physics department is also into this kind of thing. So what do? We want to apply Kirchhoff's voltage law, which says that algebraic voltage about a loop is equal to 0. Algebraic voltage about a loop, that is sum of algebraic voltage about a loop is equal to 0. So we translate this circuit into 3 loops. This is the first loop. This is the second loop. Then this is the third loop. And then just a minute. And then we begin to develop the loop equation. For the first loop, 5.1 is equal to 3 into this 3 into I1 that is coming down, and then minus I2 that is moving up, then plus 2 into I1 that is coming down, and then I3 minus I3 that is moving up. That's the loop equation. For loop 2, the principal current there is I2. So we have 4I2 plus 5 into I2 that is going this way, and then I3 that is going the other way around. Plus 3, I2 is moving up, I1 is coming down, so it's 3 into I2 minus I1. For loop 3, I3 is the principal current there, so we have 6 I3 plus 2 I3 minus I1, and then plus 5 I3 minus I2. From equation 1, we get that 5.5 is equal to 5 I1 minus 3 I2 minus 2i3. And from equation 2, we gather that 0 is equal to minus 3i1 plus 12i2 minus 5i3 when we open the bracket. And then from equation 3, we're able to get that minus 2i1 and minus 5i2 plus 13 is equal to minus, 0 is equal to minus 2i1 minus 5i2 plus 13i3. And then from those equations, you can now establish the state matrix of the system, which is 5.5 is equal to 5i1 minus 3i2 minus 2i3. 0 is equal to minus 3i1 plus 12i2 minus 5i3. And 0 is equal to minus 2i1 minus 5i2 plus 13i3. Now, this is the state equation. This is the state matrix. This is our voltage. The state matrix represents the resistances in the circuit, while the current is represented by I. When we arrange that equation in form of AX plus times B, A times S equal to B, we get that R multiplied by I is equal to V. And then the solution, as we saw earlier, will be I is equal to inverse of R multiplied by V, or I is equal to R backward division V. So let's enter the matrix into our equation. This is what we have here. This is what we have. We have that we can clear the whole of this, or clear this. We don't need this for now. We'll remove it. Okay. We don't need this for now. We'll take it off. So we have that R is equal to 5 minus 3 minus 2. That's the first row. And minus 3, 12. And then minus 5, that's the second row. And then minus 2, minus 5, and 13. And that's the third row. That's our resistor, the matrix resistor. And we have that V is equal to, it's a column vector, V is equal to 5.5, that is the first column, 0, that is second column, and 0 again. We are looking for I, so our I will be equal to inverse of R multiplied by V. Excuse me. So we said that the current, we can call it current, that is current as a vector now. Current as a vector is equal to I. Let's run it and see what we get. First of all, we run it. So I is equal to 1.6756 and 0.6267 and 0.4988. I want you to observe that from that figure that the current passing through, let's go to the first figure. The equation itself. So the current passing through the I3 from this solution figure will be equal to I1 minus I2, I1 minus this I2. The current passing through 4 ohm resistor will be equal to I2. The current passing through 5 ohm resistor will be I2 minus I3. And the current passing through the 2 ohm resistor will be I1 minus I3. The current through the 6 ohm resistor will be I5. Hope I'm correct. I5. Sorry. Okay, current passing through the 6 ohm resistor will be equal to this current, which is I3. How do we go about it? We can now come back to our MATLab and compute accordingly. So we say I3 ohms, I3 ohms is equal to I1. Okay, we have not actually extracted what is I1. Let's extract what is I1. Let's first of all extract what is I1. I want you to observe that this is a column vector. So this is I1, I2, I3. I1 is equal to current, first row, first column. I2 will be equal to current, second row, first column. It's just a column vector. So we don't have more than one column there. Then I3 will be equal to third row. When we run this, we are going to get the values of I1, I2, I3. You can see that. So we now come here. We can now begin to say that I3 ohms, that's current passing through the 3 ohm resistor, will be equal to I1 minus I2. I will suppress it. Then I4 ohm resistor will be equal to I2, and then 5 ohm resistor will be equal to I2 minus I3, and then the 6 ohm resistor, of course, will be equal to I3, and I2 ohm resistor will be equal to I1 minus I3. And then we can display the results the way we want. Display, we have You can have this inside, and then we space it. Becomes I. Okay, let's call okay, let's leave it the way it is. But if we want to make it in order, we call this one, there's no I1 here. We call this one I2, I3, I4, I5, and then I6. But then we have to be careful to, this is display. We now come and say display again, whereby we bring in the values of the components. And then we have I2 ohms. This is I2 ohms. Where is it? I2 ohms is this. So I2 ohms. Then I3 ohms. I4 ohms. I5 ohms. I6 ohms. So I think that's that. So let's execute. If you get an error, we fix the error. That is the beauty of using MATLab. You get an error, you fix it. Great. So that's it. We have been able to get this value is I doubt this I6 ohms. What is I6? Oh, that's not correct. I6 is equal to I3. So we clear the output again and run it again. So that's our final result. That's our final result. This is how to apply MATLAB in our day-to-day coursework. And with that, we have come to the end of today's lecture. Thank you for joining. You can also go through further tutorials to get the lecture internalized and prepare for the next lecture, because next lecture is going to be dealing with a complex number and array operation. Remember to like and subscribe to my channel or our channel, and share the video and comment on the video. If the video has been helpful to you, please comment on it. That is the only way you can promote this work and make us proud. Thank you very much.